we'll go ahead and get started. So our next presentation comes from NVIDIA, Berkin Kartal, who's going to give an introduction of end-to-end characterizations of HPC-AI workflows using synthetic digital twins, I guess using NVIDIA DSX Air. Berkin.
Good afternoon, everyone. I hope lunch was good. My name is Berkin Kartal. I'm working for NVIDIA since 3.5 years. My specialization is computer networks, data centers, security, service providers. So I'm not really GPU guy, but bear with me. I'm located in Zurich, so it was convenient for them to send me here. And we will today talk about NVIDIA Air, DSX Air is the full product name. So Air, it became a product quite recently, within 2026. Beforehand, it was an internal-external tool that was maintained by a group of people in NVIDIA. It came originally from the acquisition from the Cumulus side. The original intention to build such tool was to simulate a simple data center with Ethernet switches, Cumulus network operating system back in the days. And then it turned out it became like super popular and super useful. So we see the natural evolution of towards the product. To productize something, it's a good thing because it means you are working with a professional end product that has support, and you can keep certain expectations from it. So we will talk about what these expectations are and how we basically try to address AI factory needs with NVIDIA DSX Air. Before talking about mission and what we present, I would like to mention about our reference architecture and what it does. If a customer chooses to work with NVIDIA for their entire AI data center or AI factory, they start with the GPU, of course, and the software stack around it, CUDA, and of course, there are additional components in the data center, like DPUs, Bluefield DPUs, connected SuperNICs, and also the data center fabric that allows east-west communication of GPUs, inter-GPU communication, the switching network. So you have two flavors, InfiniBand or Ethernet. This is for Ethernet, what we are talking about today, and the spectrum switches. So if you would like to choose all these components and all these variations, we need to offer you an architecture, some sort of cookbook that the customer can easily deploy and get the best performance out of it. Because there are so many things that you can do all these equipments randomly. There are so many functionality. In order to get the best AI performance, the RDM, the Rocky performance with this tooling, it needs quite some work. Also, of course, there are a lot of moving components. Like there is the software on the switch, there is the nickel version that you need to use, and there is the Docker version that on the host, the firmware on the DPU, firmware on the NIC itself. So you need to have all these things somehow locked that will allow you to take the best performance out of what you paid for. And reference architecture is exactly what is doing this. First of all, it's giving you a cookbook to have the full recipe to deploy an AI fabric, an AI factory. And second, you will know exactly which software version to use for which case. And we have different versions of this reference architecture. Internally, we call it array because it's like abbreviated form. You have different versions of it. Of course, always the latest version is the best one. Because first of all, like nickel is improving constantly. The drivers are improving constantly, and also the functionality we develop on top of switches is improving constantly. In one version of Array, we are focusing on improving routing convergence. Another version, we are focusing on, let's say, congestion control improvement. Another version, we focus on telemetry improvements. So it's like constant evaluation, also architectural changes, single plane, dual plane, quad plane. It gets like really, really, really bigger and bigger. So that's why reference architecture is very important. And the second thing what is extreme, it's actually what drives reference architecture is in NVIDIA, this is called time to AI, time to first token. It sounds like a marketing term, but we are trying to really get the customers, people, to get the maximum performance out of what they choose as quick as possible. So in order to make this time frame from the customer places an order until they get the first AI token, to make it really short, we need to give them very concrete tools, documents, and material that this thing can be deployed very, very quickly. And this is where DSX Air comes into play. So the mission of DSX Air, accelerating AI adoption by simplifying the consumption of NVIDIA AI factories. So basically, it's in line with this faster time to token, faster time to AI mission in general. And to do that, we provide this digital twin service, AI data center digital twin service, with NVIDIA tools and the ecosystem. Ecosystem is our partners, which are, some of them are here today. And Air initially started like a rather simple switch simulation tool that we would bring up a certain cloth fabric on the platform with certain hosts, and you would configure EVPN VXLAN, certain control plane functionality, and you would have basic data plane connectivity end-to-end with EVPN VXLAN. It became a product because, first of all, it needed a certain type of support. One of the major drivers is the scale. In the past, it was best effort product, so you would spin up resources if they are available, because we have two flavors of it. One of them is internal that we use ourselves. I spend a lot of time with it. We have another flavor which is external to the public, to whole world. And resource meaning like you have to spin up lots of simulations, and it will consume quite some cycles from your CPUs, from your memory, and this, in the end, it has a burden, and also it needs to be supported officially. So that's why we introduced it as a product, and scale is one of the major focus at the moment. The other one is NVIDIA simulated infrastructure, that we have different components within and external that needs to be included in the system, like switching software, DPU, GPU at some level, and of course that GPU here is a notion of simulation, so it's not an emulation of actual GPU, because that wouldn't scale, and it wouldn't make sense technically also. But the whole idea is deploy this environment, this AI factory environment, in NVIDIA Air, and measure everything beforehand, validate everything beforehand, before you do it in real life. And do it as fast as possible, and try to get as much as data out of it before, an experience out of it before you've experienced it in real life. Because once you are seeing certain things in real life, it's probably too late, and it will consume a lot of time when you are working on it. Other one is the ecosystem. Ecosystem is the external partners. There are components that we don't produce, for example, storage, security, test traffic measurement, test traffic generation, orchestration. We have a tool, but it's not a product. It's not really, there are like professional tools in the market that they do this much better than us, AI fabric orchestration. And we work with all well-known partners, and they have their own solutions in air as well. And they help us to offer a comprehensive AI factory simulated AI factory to our customers. And in the ecosystem, we have storage partners, as I said. Everyone brings their simulated component. And what AIR does is it stitches, or let's say it connects the dots between different products, tools, and technologies. Also your in-house made coding, scripting, in-house tools based on x86 architecture or as well as ARM architecture. So we are able to emulate this as well. And it connects all these dots. It gives you a complete digital twin of a AI fabric. And one of the things that I use, for example, personally very often, and I would promote it, like using the CI/CD. We have the ability to integrate the whole thing with the CI/CD pipelines, CI/CD workflows. So you create your if you have existing pipeline, you can integrate this into your testing cycle together with AIR, and you can offload your validation more or less seamlessly from an on-prem testing environment to a simulated environment on DSX Air. And you will get rid of the burden of maintaining a very costly testing environment that would consume most of your time to upgrade, maintain the hardware, maintain the software. Air will make your life very, 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 very easy. At least it made my life very easy. I'm using it since the day I started. In fact, they opened me an account even before I started in NVIDIA. So I got, because they wanted me to, hey, check, this is the Cumulus switch we have. And they gave me an account. I was like, wow. Because I worked for testing companies before, that we were providing professional lab solutions, virtual lab solutions to the market. And I was blown away with the simplicity. But at the same time, if you go into details in the SDK level, on the API level, the comprehensiveness. So you can create like extremely large simulations, and you can start it, you can shut it down, you can control individual elements, you can interact with VMs, you can send certain code, and you can get it executed. And we do have, I will show you later on, we have a lot of pre-canned labs, which we call Demo Marketplace, and it would address most of your requirements. Even if this is not covered, you can create your own. And if you are a little bit geeky, and if you would like reproducibility in your testing, you can do this via API or SDK. And this is like super powerful. You don't even need to see the GUI, although GUI is super fancy. So why AIR? So this whole thing basically relies on faster time to AI, which we talked about. The whole thing is to introduce scalability, elasticity into simulation. In the previous environment, we had to, the tool phase, we had to literally, physically add servers, where at the moment we are able to use the public cloud's elasticity functionality. So we can really literally scale in an unlimited way. Of course, it has commercial impact, but yeah. On the other hand, on the ecosystem validation, We also provide the air connectivity, air access to our partners so they can develop their own solutions around it. Certain solutions, they require full fabric connectivity. For example, you are developing a fabric orchestration tool that you need a real fabric, some sort. You need like management access, you need telemetry, you need actual control plane, you need like BGP, BFT, everything is functional. And you need some sort of data plane. So we provide this connectivity to our partners, and they develop, they build their own products around it. And this is one of the things that makes AIR quite interesting. So it's not an internal experimenting testing tool. It became a product that addresses actual needs of partners and customers. And so there is some prediction on how we can reduce deployment time, software bring-up time, infrastructure validation. So deployment time is like, it makes things extremely easy. You basically define your entire topology in a JSON file if you are doing custom topology. And within this JSON file, you define your nodes, you define your switches, you define your GPU nodes and DPUs and everything. And you basically interconnect them. And then you give it to AIR. AIR brings you up the topology with the software versions you want, with the connectivity you want. And you can even choose to keep it down just to do certain testing. And you can start it, and you can realize the topology. You can make sure that the topology is up and running. And you have an entire AI factory within minutes. Of course, you need to do some preparation beforehand. And then the rest is, the software bring-up is actually also quite simple because everything comes up with the software that you would like it to come up. And the remaining is up to your validation process, how you would like to go through and what kind of functionality. We are approaching more and more to the data plane. We started from pure control plane. But we are more and more implementing data plane related things. Some things are still experimental, some things already deployed, but it's an ongoing process. And one of the things, the advantages, it's a product, it has an actual roadmap. And the roadmap is like really, we are really working on it. So it's not just like, oh, well, drop me an email, I'll have a look if we can work on it or not. No, it's not really like that, it's proper roadmap. Yeah, so certain prediction how much it would save you time on certain tasks. Especially one of the challenging things in the AI factory fabrics is the multi-tenancy. We have seen in our own lab testing as well, to even control plane-wise, to maintain and manage, provision this environment, it's quite some task. Also, in SpectrumX, the technology that we are, the solution that we are using to interconnect GPUs on internet fabrics, we are aiming at giving equal service, equal bandwidth to all the tenants. So all the VRFs on the fabric, they need to achieve the same peak bandwidth. They need to be able to use all the resources in the same way. And to validate this, to check the telemetry counters and everything, this is like a task by itself. Another benefit of using AIR, we are able to provide access to certain upcoming hardware before it is taped out, before the chip is being prepared, before the software is ready. For example, we have upcoming Spectrum 6, as well as NVLink 6, so that we are able to give this kind of access to our customers before these systems are being released and before they are physically on the market. Of course, like, this is not full-blown functionality, but still, it's very important to see, like, every new chip, it comes with certain changes, certain, like, modifications. It's important for customers to be able to put their hands on the system, somehow integrate it into their automation system, integrate it in our in their provisioning environment, also telemetry environment, to see what kind of counters they can pull using telemetry, what they can configure and how they can configure. This is extremely crucial, and we work on this quite hard. And the type of things that we are, so at the moment we added like NVLink 5, NVLink 6 is also up. This is not, it's about to be GA, I think, NVLink. If not, we open access to people, to customers that they request, upon request. So some of the problems that AIR is solving, as much as it can, this is what we call shift left. So ability to access to some hardware, some specific hardware before it's available, physically available in the market. Democratizing AI without compromise, so it's like making it available for everyone as much as possible. And so you don't need an entire AI fabric in your backyard, in your garage to develop some software for it. And sizing and resourcing constraints, how to tackle with this, how to foresee, because most of the dimensioning guidelines, although they are calculated very precise, they are theoretical. So certain things, you need to spin up the environment, and you need to observe how what kind of resources it will consume under what conditions. For example, telemetry definitely consumes a lot of resource on everything. So once you disable telemetry, systems consume less RAM. Once you enable telemetry, you start consuming much more significant amount of memory on your equipment. And this is something to keep in mind, and this is something you can directly observe on AIR. So we have some security partners that we work with, and they help you introduce security element on top of AI fabric. Like very interesting solutions are out there, and to see how this functions in the data center, in the simulated environment, before you decide to even consider such solution. Because security, it comes with its own pros and cons, and you need to really work on it. You need to have a different type of mindset. Also for KV cache memory calculations, it has some benefits. Okay, I'll show some screenshots. I have a 5-minute video prepared by my colleague. I was initially thinking about doing a live demo, but to be honest, I got a bit scared because, like, demo effect, you never know. It happened to me with many other things before, so I have unfortunately, some career experience on demo effects. So I didn't want to get into the same situation, so I have a recording. It doesn't mean that I'm not confident about the system. It's totally the opposite. It's just I don't trust Murphy. So this is, maybe I switch forward to show the demo without exceeding the time. And I'll come back to roadmap. Let's see if this will work.
Let's look at the GTC 2026 DSX Air AI
Okay, I can do voiceover.
Digital Twin Lab and partner integrations.
I think we can't.
First, we will verify the infrastructure components are working together. We will then run workloads on the integrated system and discuss
In fact, it should be possible, right? No, it's not possible? Can I? Yes. There should be, like, I want to, yeah, we could do manual.
NVIDIA has partnered with 6 vendors in a mutually beneficial partner program. Vendors get to showcase their product working out of box in DSX Air using the NVIDIA stack, and DSX Air gets to expand its ecosystem. Each vendor created a standalone demo in the demo marketplace for the respective product, while NVIDIA has built a large lab showcasing a complete AI factory simulation, and all the vendors working together with various NVIDIA technologies. Let's boot up the lab. Here we see the topology for the lab in DSX Air. It is a 16-node RTX cluster connected on both a north-south and east-west fabric. We will be showcasing RAFI, Netris, Keysight SitePerf, the checkpoint firewall, the Trend Micro Vision 1 sensor, and VAST Data VSS Blueprint. We are also running NVIDIA Base Command Manager for DHCP management, Run AI for workload management and GPU orchestration, and NVIDIA NetQ for telemetry. First, we're going to look at Run AI. Observe that we are simulating 16 GPU nodes on our cluster, with 8 GPUs simulated on each of those nodes, for a total of 128 simulated GPUs. Observe here that each RTX node is simulating 8 RTX 6000 GPUs. Infrastructure orchestration is managed by RAFI and Netris. RAFI handles the compute orchestration, while Netris handles the network orchestration and isolation. In RAFI, we've created 2 organizations called Voyager and Endeavor. Within these, we've assigned 8 RTX nodes each. If we select the Voyager organization, you can see which nodes are assigned to Voyager. If we look at our Endeavor organization, we can see the other nodes assigned, as well as the VAST storage node. Let's see how this translates to Netris. You can see our 2 server clusters here. Again, one for Endeavor and one for Voyager. Observe that the same nodes as we saw in RAFI are present in either cluster here in Netris. We can also observe our topology in Netris. Keysight SitePerf provides performance testing and validation of the infrastructure. It simulates traffic and workloads, as well as other performance metrics to verify the infrastructure is performing as expected. Our sample test here works by running HTTP requests between a client and a server agent. When we run the test between the client and server on either tenant, we observe that the iterations fail and no requests get through. When we run an identical test on agents within the same tenant, we observe lots of throughput and successful requests. Now, we'll demonstrate security and policy enforcement at the network layer with the checkpoint firewall. A blue field is also used by Checkpoint to process security policies. We've created a rule here where RTX 07 and 08 can ping 09 and 10, respectively. Let's just talk about 07 and 09 for now. Both of these nodes live in the Voyager tenant. Observe the IP address of N09. If we ping N09 from N07, you can see it is successful. Now, I've just set the policy to drop and given the SIM some time. We can see in real time that the ping has stopped now. And if we try again, we observe that the ping is indeed now dropped. Now we can look at the telemetry in NVIDIA NetQ. We can look at our switches running in our fabric here. We can also view BGP sessions, as well as EVPN sessions. Observe the VRF and VLAN mappings representing isolation between Voyager and Endeavor. We can also view our topology. The Trend Micro Vision 1 sensor analyzes telemetry collected via Bluefield memory introspection to detect malicious workload behavior. It then sends that data to the Trend AI Vision 1 SaaS platform. Observe that no logs are present. Let's simulate a malware attack on our hosts. Now, when we check back on Vision 1, we can observe the logs trickling in. Notice that they are indeed generated by our N04 host. Now, we'll demonstrate RAG-based access control and inference at the second level of fidelity by running a workload on VAST video search and summarization. Here, you can see that we created 2 views in VAST, one for Endeavor and one for Voyager. Let's search for the same content in the videos in both views, specifically dogs playing in the snow. We observe that the Endeavor view contains videos returned by the search that the Voyager view does not return. Everything we just did happened before any cable arrived to the data center. We verified each vendor software played together nicely both with the NVIDIA stack and with each other. Network engineers can then incorporate configuration and deployment into CI/CD pipelines and move the entire orchestration into a production environment right away. You've already done the testing, the validating, and the experimenting in the safe sandbox environment provided by DSX Air. Thank you to all our partners for bringing your solution into NVIDIA DSX Air.
So yes, to show the demo marketplace, this is how it looks like. I'm also contributing here. I do the VPN labs myself, and also some of the BCM, base command manager related labs. Basically, I need a lot of repeatability in this kind of environment because my task is to spin up a marketplace item with every release we have. We have 5.10, 5.11, 5.12, and they need to be exactly identical, but with a newer version. So Air and the automation environment is really ideal for this kind of task because there is like absolutely zero margin of error, and automation guarantees that you have full repeatability. Very briefly about our roadmap. So at the end of the year, we will GA our NVLink simulation. Also, we are going to introduce containerized nodes, which is something that we should have already had, but it took some time to roll out. And we are going to give the possibility to people to make changes on the fly when you are running the simulation. At the moment, you run the simulation, and you can't make any modifications on the actual nodes and the topology. So you can just connect them. You can, of course, make modifications on the file system, etc. But you can't change the topology. You can't add any additional node. You cannot create links on it. You have to stop, and you need to create again. So we will have this capability that you will be able to add, remove nodes and links on the fly. And there will be some additional scenarios that we will be introducing to address more AI factory use cases. This is the end of my presentation. Before I leave, I think I have 5 more minutes, which means I have time for questions.
Do you have a question or just
Should.
Thanks for the presentation. It's a very interesting tool. I'm wondering, when it comes to the predefined topologies for network, like Fat Tree, Dragonfly, or the one that's known already, or any research in new topologies, are you able to build,
You can build anything you like. What it comes itself, what we built, is all closed topology. Usually we do 2-tier. We also started doing 3-tier. For AI deployments, we have multi-plane topologies as well. Dual plane, quad plane, but only specifically for AI topologies.
Okay.
You can implement, of course, Dragonfly and other type of interconnection methods, like different type of multi-homing, because it was quite popular in the industry for some time, like to do multi-chassis lag, that we don't promote anymore. We promote EVPN lag. But in AI topologies, no one is doing it because every rack is connected to their own Tor. It's a totally different mindset. If you lose a couple of nodes, you basically, these big players, they take out the entire rack.
Yep.
So it's like, there's like different motivation.
Yeah.
But we can implement more or less any kind of topology.
Yeah, and from the network technology also, can you go back with technologies just because you want to mimic an older version, HDR, NDR,
Which
SDR?
I would absolutely not do, but if you want, you can do spanning tree.
Okay.
But, yeah.
Yeah, okay, interesting. And this is free, this tool, is this a payment or is this free of use?
So, in the past, it was a tool, it was not a product, it was free, and we were not able to give the scale that people needed. Okay. And we were not able to give the professional support. Right now, there's professional support and the scale. So I don't know about the commercial part because I'm on the technical side, but there are like bundles, subscription bundles, that certain bundles you can have, but after that you need to
do some. Okay. Yeah. Thank you. Any question?
We have Python SDK, API, so like the full programmability.
Yeah.
Thank you.
Okay. Thank you very much.